So the topic today will be triple integration by change of variables. So basically, we will be performing this operation on a specific coordinate system that is called as a cylindrical coordinate system. Okay, so first let us try to understand the basics of it. Cylindrical coordinate system, right? There are various types of coordinate system. That's what we have. Now let's try to consider the XYZ coordinate system first. Then we'll try to extend that to the new coordinate system. All right. So let us assume if you have a coordinate system denoted like this, right? That means, right, what are the various components you have? Let me say this is the x-axis, this is the y-axis, and this becomes the z-axis. So if at all I want to draw, say a change of color. So any point I want to mark on space, right, will actually I have to use this. Copy this and I'll paste this. Or yeah, just a second, just a second. Okay, so now you see any point in space requires how many distances? I have to measure three different distances, correct? One distance along every distance along each of the axes, coordinate axis, how much you need to move, right? That's what represents my value, correct? That's the value of the coordinate. Okay, so this is how you try to measure that. I'm trying to give a demonstration over here. This is anyway, we know that, but anyway, this is going to be helpful when I shift this coordinate system into the other coordinate system. Okay, so let's say this is my point. I'll change the color to represent the point. The point is here. Okay, so in case of a rectangular coordinate system, every point is considered as a corner of a box. Okay, so this point, right, how do you measure this point, how do you represent this point? Has three values: p, one along x, one along y, and one along z. So that this is how the measurement takes place, right? How much ever you move along this distance is the x value, correct? After reaching this point, you move so much distance along y axis, right? After reaching this point, you move so much along the z-axis. So how much you move, it doesn't matter which direction you move first, correct? So I move so much distance along z-axis first, I reach this stop point. Then I move something along y-axis, I reach this point. Then I move so much along x, I reach the same point, right? So it doesn't matter the order in which you traverse. Okay, right. So this is the simplest form. Most commonly and widely used form, that is called as a rectangular coordinate system. All right. Now you see our objective is to measure the same point, but not on this particular system, but on a different system. Now the question may definitely arise: why do you want to use a box kind of representation? Why not any other this thing, right? So answer is yes, you can use others as well, right? So let me try to draw that. Okay, let's try to write the similar one here. So this is for the cylindrical coordinate system, the same x and y axis I'm trying to draw now. Okay, so this is the x and this is the y. So, but x and y will not come into picture when I am trying to write. Look at that. All right, fine. So that means I need to draw a cylinder first. So for that reason, let me try to something. this is the point, and I need to consider, I will also consider the z-axis, right? Z-axis will also be there. And into another cylinder. Let's see how this. Okay, I'm doing this to submit. Okay, let me try to finish the cylinder and the sides. Assume that this touches. Okay, all right. Fine. Now you see what we are trying to do here is the same point which we marked over there, right? Using the rectangular. Let me say that it is the same point, right? So same point I want to mark. This is where here. This is the point, right? This is the point P. But now you see I don't want to represent that, right? Using the what you call two distances. I don't want to use maybe all distances. I want to change this. So whenever it comes to the cylinder, now you see how do I reach this point on a cylinder? It's present on the top surface of the cylinder, right? Okay, now you see what I do. First, we'll try to drop this particular point to the XY plane. Okay, so that means I'm trying to drop this like this. I'm trying to find the image of that particular point on the xy plane, because it comes to the upper surface only by adding a distance, right? Distance along that axis. That's the z axis, right? So it means I don't have to do, in order to find where is it located on the surface of the disk, right? In order to find out that, I don't need the height. I just need the x and y to do that. So when I do so, I understand that from the center of this, from the center of the circle to this, what is this? This is called as a radius. I need one parameter, that is the radius. So one of the parameter is r, distance, right? You use distance, but it's not a distance which we used earlier. It is a radius of the particular cylinder. Okay, fine. So I got that. And the second parameter could be, right? Again, this is taken as some standard reference, right? There is no, right now there is no answer why you are measuring the angle only with respect to this. It's a convention, right? So the convention is like you measure all the angles, right, with respect to which axis? It's always with respect to the x-axis, correct? So that's why right now we are trying to measure this angle and writing that as a theta. So that's your second, right? This thing, second coordinate in the cylindrical system. And the third cylindrical system, third point is nothing but, in order to reach this point, you have to climb a height, right? So this height which you need to climb, that is still the z-axis only. You see, z-axis still remains over there. There is no x and y axis in cylindrical coordinate system. Instead of that, we have radius r. R is an axis which is radial direction, radially outward, right? It can be here, it can also be here, right? No problem. Anywhere you want, you can find the radial direction, but it is always pointing from the origin, right? From the, right. So after measuring the theta, you can draw the r. That's all. Correct? Right. So the same r you can even measure here. R and theta can be measured. R can be measured even on the upper surface, provided you know the center, where the center is. Okay. Right. So this is what is the cylindrical coordinate system. Yeah, that's why. So on the top, I may approximate it somewhere here. That's all. Okay, but still, exact measurement happens where the origin it is, right? So origin is always right, 0 comma 0 comma 0 of all the three values: radius 0, theta 0, and even the height is 0. That is the origin. So origin, so no height means it should be the bottom surface, correct? So that's why we mark that on the the bottom surface of the cylinder. Okay. So now all the questions will be right. A question is given in terms of the rectangular coordinate system, and you want to convert this into this. This is the change of variables. Okay, that's the concept, right? Let's look at the change of concept, change of the variables now. So already we have seen that in case of a double integration, you might have noted that, right? You use what is called as a Jacobian for the transformation, correct? So I want I want to obtain the term. Okay, let me try to write one parameter here. So that is, so our change of variable basically refers to this operation, right? I have triple integral, right, over a region R, right, some function f of x comma y comma z, correct, into maybe you have dx dy dz. This has to be now replaced by a triple integral over some region, say r dash. This is definitely a different region because you are trying to write the region in terms of r, theta, and z. Correct? So you have to write another function, maybe g of this can be r comma theta comma z, and I need to bring a j in picture. That is a Jacobian, because you are trying to take care of the replacement of dx and dy and dz, because they are not directly written as, you cannot directly write it as simply dr d theta dz, correct? There is a parameter z which actually helps you in the conversion of dx dy dz into this. That conversion is taken care by an operator called Jacobian that actually returns, you can write it as x comma y comma z. I want to measure the variations of x comma y comma z with respect to my new variable r comma theta comma z. Okay, this is the one which helps you in the conversion. So now first of all I need to understand what is this j, how do I write j. But let's look at the uh, representation once again, right? So x is the distance along x-axis, y is the distance along y-axis, right? Z is the distance, z was measured as a distance along the z-axis, but the same thing remains here. So there is no change in the z of rectangular and the cylindrical. So z remains same. In both the cases, height is still there, right? So that's the first point. Let's try to write the required equations, right? Let's try to write the relationship, right? So second one in the sense, which one? Sorry. No, g is not in terms of x, y, z. G will be r comma theta. G will be, huh, I'll come to that. I'll come to that. Okay, I'll update, right? I'll update this equation, but before that, I need to find the j value, the value of the j in this case. Is it okay? Right. Okay. That means, let's say z is equal to z in both the, right? I'll try to z as z itself on both the cases. But I need to understand what happens to x now. What is x? X in the rectangular system equal to what? The cylindrical system. So x means what? This is, right? You see the diagram. I'll change the color. I'm trying to measure, I'm trying to plot this point onto this line, correct? So this is my x value, isn't it? So can I write it as r cos theta? R cos theta. Similarly, try to measure this, right? That's the y value. That is r sin theta, right? So x is equal to, this is r radius cos theta, and y will be r sin theta. So anyway, I'll come back to this point later. Now instead of x, y, z, I can still keep the f as it is. but no x, x becomes r cos theta here. Okay, no theta. So second parameter, instead of that y, you can write r sin theta. Height remains same. So f of, I can still retain the f itself. Okay, that's what was the was my point. But I'll come back to that later. I will first find the value of j now. Jacob, is it okay? So let's try to find j now. So what's the equation for j? If you remember, right, j is actually j is written as its derivative of x comma y comma z with respect to r comma theta comma z. So now since there are three variables, right, to be differentiated with the three other variables, this is a 3 cross 3 determinant. What is that? This is dou x by, first row, first we try to find out all the variations with the all the variations of x itself with all the three variables in the first row. Dou x by dou r, dou x by dou theta, dou x by dou z. Similarly, second one, that is dou y by dou r, dou y by dou theta, dou y by dou z. Then this is dou z by dou r, dou z by dou theta, dou z by dou z. Hope this equation is clear. All right. Now you try. Now you know the equations, right? On the left hand side, you can see what is x, what is y, what is z. So I can definitely write what is dou x by dou r. Right? If you differentiate x with respect to r, you are going to get a cos theta. Right? Differentiate x with respect to theta, cos theta becomes minus sine theta. So this is minus r sine theta. Then anyway, there is no meaning in differentiating x with respect to z because they are independent. So you have answer 0. Okay. Next, dou y by dou r is sine theta. Okay. Then you have uh, dou y by dou theta. So sine theta becomes cos theta. So this is r cos theta. Y is independent of z. Next, z is independent of r. Z is independent of theta. Dou z by dou z is 1. Okay. So expanding, this is directly 1 into uh, r cos square theta, right? R cos square theta plus r sin square, correct? Cos square plus sin square is 1. So this is simply r. So the Jacobian becomes equal to r. Okay. So that means I can rewrite this implies the triple integral. Now you see only the region changes. That's all. R, right? A function of x comma y comma z, right? Into dx, maybe dx dy dz can be rewritten as integration over a different region r dash. But you see, I'm not changing to g, I'm writing f itself because I know the substitution. What is x? Every x has to be replaced as r cos theta, correct? Every y has to be replaced as r sin theta and keep you retain the z as is, correct? Are you fine? Into the Jacobian, which is r, right? Into dr, d theta, dz. Are you okay? Let me know if you have any doubt, otherwise we'll proceed. No, z is always fixed now. You don't have to change the z. I'll show you what it is meant when I say don't. Z is not going to change. No, Z is Z itself. You don't change the Z at all. If at all, in the sense, right? For example, let me say I have 4x squared plus y squared plus 2z is my equation, f of x. Correct. When I convert this into the cylindrical coordinate, right? This becomes 4. What is x? R cos theta whole square. Plus what is y? R sine theta square. Plus 2z, no change. Remains as it is. Okay, so that's the meaning. Because in both the coordinate systems, right, there is a component of height needs to be measured and it's measured along the z-axis. So you keep it, you retain when you convert. Okay, so this is the question. So solve equal to triple integral over a region R. This is 4xy into dv, where R is bounded by z equal to 2x square plus 2y square minus 7, and z is equal by using change of variables. So I have to, anyway, so if you apply the yesterday's method, you can solve directly. You don't have to worry about that, right? But this question is about you have to apply the change of variables. In the sense, you need to convert this into the required format, right? So required format in the sense, in this case, it is cylindrical, right? So I think for your syllabus, only the cylindrical is there, right? You have the spherical coordinate system as well. Absolutely fine, right? So next class will be doing that. Okay, fine. No issues. So now from this given data, I understand that z has a limit. Minimum value of z is 1, maximum is given by the equation 2x square plus 2y square minus 7. Okay, so that's the point, right? So I understand that. Okay, this is how the z weighs. Correct? So this implies, let me start solving by identifying. First, I need to convert everything, right? I can definitely convert 4xy into the required function, 4 into r cos theta into r sin theta. Okay, that's anyway, we can be done. But the important point here is to finding out the limits of r, theta, and the z. Again, the z limit is given, but I cannot use the same limit because it contains x and y. I have to replace this with the r and theta. Okay, so let me write. So 2x squared plus 2y squared minus 7. This is the, it should be between, bounded between, right? Which means this is the lower one. Okay, between, they have given two values. So always lower and this is upper. Okay, so lower limit is given as the equation. So this is lesser than or equal to the z lesser than or equal to 1. So that means, right, I can try to relate this with what is called as the the cylindrical parameter. So what you do, you try to replace that, right? What is x square plus y square equal to r square, correct? So 2 times, I take 2 outside, I have x square plus y square, which is 2r square, correct? Minus 7 less than or equal to z less than or equal to 1. You see, you converted your limits given in the uh, xyz coordinate system into the r theta z coordinate system, correct? So you got a limit. This is the limit of z. Are you fine? Right. Now let's say the height is 0. Fine. Let us say that there is no height for the time being. Right? Once again, okay. I'll write like this. I skipped actually one step. So I'll do this. X 2 times x square plus y square minus 7 less than or equal to z less than or equal to 1. Is it okay? Now you see, what is x square plus y square? What is x square? X square is r square cos square theta, right? Already we use it in polar system, right? What is y square? R square sin square theta. R take out r square into 1, right? So it's simply r square. So 2r square minus 7, right? Equal to r square. Apply this over there, you got this. This is the limit for r. Now, right, in order to identify the, say, this whole boundary, they have given a condition that it's bounded by z is equal to this term and z is equal to 1, correct? So two values of z have been given, right? So two values of z have been given, indicating that I'm trying to find out a surface which matches this condition, correct? Now you see, anyway, my intention was to solve a triple integral in which this integral is over. I could identify that that's the limit. I actually found an equation and I solved that. That's over now. So I have to still perform a double integral, correct? Double integral means it has to be a surface, right? I have to do an integration over a surface, right? This surface has to be represented by using r theta only because z is eliminated now, right? In order to relate r, you eliminate z and you try to relate the other parameters, you equate them. That's the method, right? In the sense, so try to relate this. So what they have given, right? So okay, so this is what you do. You try to equate the values. So they say z is less than this something, so that is 2x square plus 2y square minus 7. Right, now z is eliminated, right? So this, maybe this is somewhere the top surface, okay? There is one top surface and one bottom surface, right? Something like this. Now I actually eliminated the height, means both should be present on the same, right? That's what I'm saying. You equate it, you equate them, equate it to 1, so that you understand what is this surface now. Z is gone, you don't have a z, right? You are equating the other term. So what is this now? If you can look at this, this is 2x square plus 2y square. 7 goes to other side as 8. 7 plus 1, right? So this is x square plus y square equal to 4. So this is radius equal to 2 and it's a circle. I understood that. So now you need to find out the r and theta value corresponding to this circle, right? So bottom and the upper one was a circle actually. They represented a circle. So what is the radius? Radius is fixed. This is, right, 2. R is equal to 2. And you know that the complete theta, so theta should be 2 pi. 0 to 2 pi. So you could understand that, correct? Are you okay? So let's write, therefore, right, the required integral I is nothing but, so first you will perform the integration with respect to, first always the theta comes as a last integral, so theta is equal to 0 to 2 pi, then I'll do with respect to r is equal to 0 to 2, then you do with respect to the z starts from the lower one, if you remember, that is, I think we got 2r square minus 7 till 1, right? Right. So then right. This is 4. X is what? X is equal to r cos theta. X is equal to r cos theta. Then you have, there is a y. So y is equal to r sin theta into, there is a Jacobian coming up, that is r. Then you write according to this. This is dz, right? dr d theta. Are you okay? Right. Let's do the integration. So this is equal to 0 to 2 pi, 0 to 2, right? What happens when you integrate with respect to z, right? The terms remain as it is. 4r into r into r cube. I have cos theta into sin theta into, I think we have a z coming into picture, right? So that is a z. Substitute 2r square minus 7 till 1 dr dt. That was a no, no, it's not combined. You see here, this is my condition. Z is minimum is 2r square minus 7, maximum is 1. So lower limit is 2r square minus 7, maximum value is 1. Okay, that. So even in the integral, it's written in the same fashion, right? So when I wrote the equation, you can see here, this one, it's lower limit. Okay, so 0 to 2 pi, 0 to 2, right? Then after this substitution, what happens? We need to calculate, right? So the z is 1 minus, what happens to z? Let me write. So that is 4 r cube theta sine theta. So first z becomes 1 minus 2r square plus 7. So I can write it as directly, I'll skip one step. So this is 8 minus, correct? 8 minus 2r square, then cos theta sine theta dr d theta. Right? Next I'm going to do with respect to r, right? So I think I can do that easily if I take either you multiply the r inside, that's also fine. The 4r cube can be multiplied. That should be easier, I guess. But otherwise, we keep 4 outside. 4 integral 0 to I, integral 0 to 2. So this is 8 r cube minus 2 r to the 5 into, that is the sine and cos, right? Cos theta sine theta dr d theta. Yeah, okay. Now you tell me what we are going to do. So this has to be equal to 4 times integral 0 to 2 pi. Let's do the integration. 8 r to the 4 by 4 minus 2 r to the 6 by 6. Right? Substitution should be 0 to 2 cos theta sine theta d theta. Right? Since the upper limit is right now 2, right? Only that will be coming in the picture. So this is equal to 4 times integral 0 to 2 pi. What happens when you put 2 over there? 16. So anyway, this cancels with this as a 2. This is 32, right? First term, 16 into 2. Okay, what happens to the second term? This is 2 power 6. Anyway, I'll cancel this as 3. So what happens to the 2 to the power 6? 2 into 2. So 4, 4, 4. 64, right? Right? 64 by 3, I guess. Isn't it? When you put 0, it cancels out. So simply we have, this is cos theta sine theta d theta, right? So what is this value? 32 minus, let's try to write it. So there is a 4. 4 multiplied by 32 minus 64 by 3, right? Okay, let's try to write that. That is 128 by 3. Let me write it that way. So this is 128 divided by 3, integral 0 to 2 pi. I have cos theta, sine theta, d theta. Yeah. How do you solve this? Hmm. Okay, I can take 2 from 128, right? So this becomes 64 by 3, integral 0 to 2 pi, right? 2 comes in. So 2 cos theta sine theta is sine 2 theta, right? Sine 2 theta d theta. So what happens to this? This is now, anyway, 64 by 3. Sine theta integration is minus cos 2 theta, correct? Divided by 2. Okay. Okay, one and same. One and same, right? Anyway, I'm doing that in this way. So this cancels with this as 32. It's not even, right? It's odd function. Sine is odd. Sine is odd. You see, now it becomes 0 ultimately. You see, 32 by 3, right? Into, anyway, minus, I'll take it out. What is cos 2 pi? 1. Minus cos 0, 1. Correct? So it's odd function. Right. So sine function integrated over complete period is 0. Right? That's the answer. Okay, so anyway, we just started with the conversion, right, of any given function into the other. Let's let me see if I can another equation. Okay, this is the next question. I equals to triple integral over the region R, and we want to solve e to the power minus x squared minus z squared dv, and R is the region between x square plus z square equal to 4, comma, x square plus z square equal to 9, and 1 less than or equal to y less than or equal to 5, z, z less than or equal to 0. So this is the given value by performing the change of the variables. So you see, there are two circles given, right? X square plus z square equal to 4 and x square plus z square equal to 9. So that means you have two different circles, right? One is of radius 2, one is of radius 3. Along which plane it is, that it has been given xz plane. I have to draw the xz plane with the two circles. That's the first thing. Okay. Uh, no, I ultimately want to first find out what is the given range, given this thing, so that I can find out what is the range, right? I can try to find what range they are talking about. Where is this region if you try to find out, right? Then definitely we can easily go ahead and, right, solve the integral. Right. So you see, it's a complete circle, first thing, right? Uh, Okay, okay, let's try to. Now, no, no. This is going to give you some idea. Say, let me consider that this is my XZ plane, right? Whatever I'm writing here itself is a XZ plane. Okay. So, sorry. Y varies between this so that I'll try to convert this into a 3D diagram later only if required. Okay. So this is X, this is Z. Let me assume, right? There are two circles. Let me try to draw. Let me say this is the circle number one. And also I have another circle, right? Slightly bigger than this, correct? Let me try to make it maybe somewhat. Okay, fine. So this is this, and they say one more condition. You see, Z is less than 0. That means, right, the two circles which you are going to consider is below this third and fourth quadrant. This is only this portion they are interested in. Okay. Let me just erase this for the time being. Erase the unwanted part so that I can try to extend this. I can try to make this into a 3D diagram. I'll try to do that. So I just have to copy and paste the same diagram again. That's all. So let me try to do that. Okay. Anyway, I understood that this is the z-axis. I'll write that later. So I'll just copy this diagram once again. I'll paste it behind this because you see the axis which is entering into the plane of the paper is your y-axis, correct? Correct. So, which means you see there is a variation given for z, right? Sorry, y, right? Y varies from 1 to 5. So that means along this, along the y-axis, you have to move how much? 4 units. Because assuming this is 5, it has to start at which location? It has to start at where you have to start this now. Not below, not below. It should be behind, right? Okay. Below means you mean the same thing, I guess. Am I right? Okay, so let me draw it over here. So now you see, right? Anyway, I'll try to eliminate the front part. This is what I don't want. This is the y-axis, what we are talking about now. So you see, all right, this is the surface, right? Sorry, this is the volume. So this is connected to this point. Okay, I'll change the color so that we can identify. I'll change it to red. So see, this point is connected to this along the y-axis. Okay, so these two points are connected. These two points are connected, making it as a volume node. You see, whatever is between the two circles, if you connect this like this becomes a volume, isn't it? Are you able to visualize? It's like a part. Okay, so now you see the conditions are given. One is x square plus z square equal to 4. That is this one. X square plus z square equal to 9. That is this one. It's between that. In the sense, the shaded region, black color. And they also give y varies from 1 to 5. So that means this is y equal to 1. This is y equal to 5. That's the y-axis, right? I'll try to mark the y-axis now. Let me assume. Yeah, it's in third and fourth quadrant, right? So y is actually right when you enter in. Sorry, I think I wrote it as z. Sorry, my mistake. That's a y-axis. Okay, so I hope the diagram is clear, right? Okay, so the whatever is entering into this will be our axis. Okay, now this is a given diagram. We try to understand. Now I need to identify what happens, what is the range of R, what is the range of this thing. So anyway, I think from this, two things are very clear, right? One is what is the value of radius. So let me write here. So radius varies from 2 to 3, isn't it? What is the radius of the cylinder which you are considering? Always it's directly given in this case, correct? So the rate, I'll write lower limit first. So 2 less than equal to radius less than or equal to 3. Now you tell me third and fourth quadrant range of theta. Theta minimum value is pi and maximum value is 2 pi. All right. Now the y is given. So y value is given as say 5 to 1. Okay. Now I have a question. Right? What if I tilt my cylinder? Like now you see previously we had the, yeah, sure. Please take your time. R, yeah, radius is 2 and 3, correct? So that should be the radius, right? Okay, now I'm coming to a very, this is actually a special problem. I don't need to find the z now because x and z have been used already to find r and theta, correct? Right? So that means what I mean is this. So you see, I initially I considered this cylinder like this, correct? This was my cylinder, previous case. So that this was x, this was y. I use x and y to calculate the r and theta, right? What if, no, theta is not given. We anyway we found it. We found theta is between pi to 2 pi. But you see, what we did, we never considered y, we considered z for that reason, correct? Are you okay? So let me write it here clearly. So we initially we wrote this was our original one, right? X is this direction, y is this direction. But in this problem, in order to find the r and theta, I never used y. Which one you used? You used z, right? Which means what is height now? So height of this cylinder is actually represented by the y-axis, correct? That's all. I'm ready to go. I don't have to do any change. Keep y as it is. So I'm going to replace the height parameter by y, okay? And I'm going to change, right, x as it is. The original y will be z now. So z is equal to r sine theta. That's the point. Hope this is clear. Okay, directly write the integral. Therefore, right, I is equal to triple integral. So the first one will be for theta. So theta is equal to, this is pi, going all the way till 2 pi. Then I'm writing for r, right? R varies from where to where? 2 to 3. Then now I'm writing for y is equal to 1 to 5, right? So in the equation, wherever you have y, you retain y, and others you change according to this. So for this problem, x is equal to r cos theta, okay? And z is equal to r sin theta. That's all. So you see the given equation is e to the power minus, you see now you understand why they have given x square plus z square instead of that. You see it is minus of x square plus z square, right? So that's why minus of x square plus z square is minus r square into, there is a, what I have, I think I have, okay, I need to multiply by r, right? Because that's a Jacobian, into, first I'm doing dy, then you do dr, then you do the d theta. Okay, so this is equal to, let's try to solve this. So this is pi to 2 pi. This is 2 to 3. So I'm retaining r into e to the power minus r square as it is. So there is no y, so y comes into picture. This is 1 to 5. Okay, dr d theta. So y becomes 5 minus 1, so that is equal to 4, right? So 4 integral pi to 2 pi. So your function is r into e to the power r square, correct? You can put r square as something, correct? So what I try to do, okay, anyway, I'll write this is integral 2 to 3. This is r e to the minus r square dr d theta, right? Put r square equal to t, correct? So this implies 2r dr dt, correct? So that means I have to write a dr. So dr should be equal to, what is dr? Okay, r dr is there. Sorry, r dr is equal to dt by 2, isn't it? And you replace this, then you come back. Then you come back with the r. You replace r once again, so that you don't have to substitute the limits, right? So this is equal to 4 times integral pi to 2 pi. So I have e to the minus t, right? What is the integration of e to the minus t? Is same, e to the minus t, t means r square, correct? Divided by minus 1, correct? Into, there is, I have to replace dr. Dr becomes dt by 2. Okay, so anyway, I'm going to replace the dt by 2 once again back to r. So there is only half coming into picture, correct? Anyway, dt is vanished because I finished the integration. So you don't have to do anything, right? Just d theta. Is it d theta? Yes, d theta. So this cancels with this as 2. So I have minus 2 outside, correct? Minus 2 integral pi to 2 pi, minus 2 integration pi to 2 pi. Oh, my mistake. I didn't substitute, right? E to the minus t integration is e to the minus t by minus 1. No, sign changes, right? If you don't write minus 1, no, that's right, that's okay, that's fine, that's correct. Okay, but I just follow the integration rule to write, that's all. Okay, now actually I made a mistake. I didn't substitute 2 to 3, correct? Because I got the answer, but never substitute, right? So this is, there is a minus 2, right? Integral pi to 2 pi. This is e to the power minus 3 square. How much is that? 9 minus e to the power minus 2 square, right? So 4, isn't it? D theta. So this is equal to, I think we have, anyway, I'll take, anyway, the whole thing is, everything is a constant, right? Looks like a constant. So this is 2 times e to the minus 4 minus e to the minus 9. Simply you do the integration pi to 2 pi for d theta, that is theta coming from pi to 2 pi, right? So 2 pi minus pi is a pi. So your final answer is 2 pi into e to the minus 4 minus e to the minus 9. Anyway, you can substitute the values and calculate. Okay, so that is the final answer.